Hello everyone. Today I am going to take a session on how to extract information from a NetCDF file. Let us first know what is a NetCDF file, and we are going to extract the information from the NetCDF file using the MATLAB. Already I have opened the MATLAB and I am using MATLAB R2022 version A, and it has been licensed by IIT Kharagpur for academic use. And we are going to code this in live script, and this live script will be available after 2017 version, I think. And in the live script we are having lot of advantages. That's why we are going to script in the live scripting of MATLAB. What are the advantages? I will tell you in as we progress. Now first learn what is a NetCDF file. Actually, NetCDF file stands for Network Common Data File. Its ability to store large dataset in multi-dimensional space makes it a useful tool, and most of the climatic variables are stored in the NetCDF format. Before going to the NetCDF format, first let us know what is the structure of the NetCDF format. Without knowing the structure, it will be very difficult for you to extract what are the information in the NetCDF file. And we are going to extract the information for our region of interest, and we will be using a shape file to extract the information. Let us look what is a NetCDF, and you can see that this is the structure of a NetCDF file, and this is the x-axis, y-axis, and there is also a z-axis, and there are different variables like longitude, latitude, precipitation, temperature are different variables. You can see this is the structure of a longitude, and this is a two-dimensional array, and latitude also a two-dimensional array. Precipitation and temperature are three-dimensional array. But somewhere you will find that longitude is a one-dimensional array and latitude is a one-dimensional array, or we can say that it is a row vector, or sometimes we call it as a column vector. And you can see here clearly, if we will talk about the temperature variable or any variable, you will see that this y-axis will be representing the latitude, and this will be representing the x-axis will be representing the longitude, and this z direction is very important, and this is our time direction. So what we have to do? Let us begin. What I have done initially, I have taken two NetCDF file. Let us try to process a single NetCDF file. This is a NetCDF file containing some variable, that is rainfall, and we will see how to know what is the variable inside it. And I have taken a shape file and I have named it as BBMD. Okay, and I have placed all these things in a single folder. You can see, and while saving this shape file, you have to save all the supporting files also, like CPG, DBF, PRJ, .ssp. All the files should be in one folder. You can also place it in different folder. If we are placing it in different folder, then you have to give the path length, or the path you have to give. And let us try to process a single NetCDF file, then we will go for multiple NetCDF file. This is the shape file. This is actually our region of interest. Okay, I will show you our region of interest area. Let me open the QGIS. You can have a look how our shape file looks like. Just wait for a second. Let me open this shape file in our GIS. Meanwhile, and this is the live script format, and let us navigate to that folder, and here you can set the default folder. It is in my app, I think. Okay. YouTube, then NC file, then we have set this as our default folder, and we have opened this. This is our QGIS. Let me drag and drop it here. Okay, Windows 11 actually does not support, I think, drag and drop method. You can directly navigate to that folder that is in F drive, save file, and this is our location. Actually, it is a basin in India. You can open the quick map services and see this is our location, and we want to extract all the information inside this region, and I will be calling this ROI, region of interest. Okay, and important thing is that when you are keeping the save file in that folder, the coordinate system must be in WGS format, World Geographic Coordinate System. This WGS system, that is 84. Now let us go to MATLAB. Okay, and as I was talking that this MATLAB live script has a lot of advantages. What are these advantages? Actually, we can have the preview what you are writing. After you run a script, we can have the preview. And for your easiness, what can you do? For your comfort, I will suggest you that please make your window visible like this. Here we will have the current folder or the directory in which you are working. Then we will have the workspace here. Then the command window will be here, so that it is very comfortable. And all the outputs of each line or each section we can visualize here. And all the variable that will be extracting will be saved in the workspace. Let us try to write the heading, and this is the button by using which we can write the heading. Then we can write the heading as, let us write the heading, extraction of NetCDF file. Then again we have to press code. Now basic thing is that before writing any code, let us try to clear our screen. The command is CLC. Then we have to close all the windows. Close all. Then the most important thing is that we have to clear our workspace. CLER. Like we can run our code, and we have successfully run these 3 lines. What are the advantage of 3 lines? Let me show you. If I have written some code like this, and you can see some information is stored inside our variable 1, and you can see in the workspace we have that value, that is 1, and this is the variable A. When we will be running this code, all our screen and the workspace will be clear. Similarly, if we have opened any window, let me take that A equals to 1, 2, 3, and let me plot this one. This is our plot, and you can see all the 3 things are active. We have something in the command window, we have something in the workspace, and we have a window that is open. Let us run this code. After you will see that all the things here, nothing in the command window now. Now our workspace is clear. Now what we'll do, let us break this section. Means this is one section, and we'll go to, let us try to import our NetCDF file. Let us give the heading first. Here we'll be taking NetCDF file as a input. Input NC file. Okay, Now write our code. For importing the NC file, our code is no. Let us first try to display our NC file. So our file name, here our file name equal to, in a single inverted comma, we can take this file name and write here. And we have stored our file name in this short file name variable, so that it is easy and short, we can able to access this file easily. Then run this. The advantage of making this as a section, that every time I will be running this code, I don't have to run these 3 lines repeatedly. Means I want to work this section, and every time I will try to run, I will be running this section only. I will not be running this section. All the variable above that section will be previously stored, and it will save my time. And you can see file name, and the output is visible here, that my file name is this one, and I have stored this in a variable called file name. You can see here it is a character format, and it is being stored here. Now let us see, visualize what is inside a NC file. How can we see? NC read is the code. What is which file we want to see? Then another advantage of writing in live script, that it will give some suggestion. You can easily, like NC read, you have 4 files, and it will be taking this file name. This is the advantage. Okay, you can see all the variables having file name will be linked, and give a semicolon, run it. NC, sorry, this will be NC disk. NC disk is the command. Look, now I could see, and here are 3 options, where these options, if you want to see the output in the right hand side, you can click this button, and if you want to see the output right below our code, then we have to press this button. And if you want to see the output, only the output, we don't want to see the code, then you can directly press this one. But we like to stick to this format, and after this code I want to see my output. You can see what are the things stored inside it. Source means where is the place of the location of this file, and what is this format, what is this global attribute, and these all the variables information are stored inside a NC file. But important thing which we will be more concerned about is the dimension, variable, latitude, longitude, rainfall. Okay, and let us first talk about this dimension. And it is a dimension of, you can see it has 3 dimensions. One dimension is longitude, another is latitude, another is time. Now let us try to visualize. This is latitude axis, this is longitude axis, then in the Z direction we have that time, that is 366 days, and we have variables. What are these variables? We have longitude, and it is 135 into 1, and we have latitude 129 1. This means it is a 1D variable. This is also a 1D variable, and time is also 1D variable. In this MATLAB term, we'll call this as a column vector. We are having, sorry, this is a row vector. We'll having a single column, and we'll have 135 rows. And in the latitude, we'll have a single column, we will be having 129 rows. In the time, we'll be having a single column, 366 rows. Now what we'll do, now let us go to another section. Why I am making the section? So that it will be very easy for you to understand. And let us try to put a semicolon here, so that it will not show the file name. Semicolon means the output will not be shown. Let us make another section. And what in this section we did, in this section we have taken the file name as input. Exactly, we have not taken the input. Actually, we have stored that file name inside a variable, and in that variable, using the NCDF, we have seen what are the information stored inside a NC file. Let us make another section. Let us make another heading. Here, what we are going to do, now we are going to extract our variable. Extraction of variable. These are the simple lines. These are not code. You can write anything. So that when we are going to open this file which you have written in the future, so that you can able to understand what I have did. Okay, now our command to extract the variable is nc read. Okay, you can see another advantage of live script in that it will be giving some suggestion. This might be your code which we am looking for. Nc read. Now what is the file name? From this file name I want to extract. Look, here we have got the suggestion from the MATLAB that this is the file name you might be looking for. Then the variable name we are going to write latitude. This variable name should be exactly like this. Only it should be in uppercase and the same spelling. Latitude, and this is in capital. Okay, our latitude will be stored in Y. Let's run this one. You can see I have imported successfully my latitude information from the NC file to MATLAB. Similarly, now try to extract other variables. What are my other variables? Now it will be X. What will be it? Yeah, be careful about the variables. Longitude. Good. Then we have another will be time. TIME. Then we'll have rainfall. This will be time. Then we'll be storing here rainfall. This will be rainfall. Now let us run this section. You can see that we have not executed the previous section. All the information are stored in this workspace. We have saved some time. Now let us break this section. Yes, and it is also important. Let us save our file. NC file for you. And the NC file, and it is in the same folder. Our file which we have done in MATLAB, it is also saved in the default folder. And the extension name for live scripting is .mlx. Yes, now let us proceed. Till now, what we have done? We have in this command, we have cleared the command window, we have cleared the workspace, and we have closed all the windows. Then we have stored our file name inside a variable, that is file name. Then we have displayed the NC file and all the information inside it. Then we have extracted all the information that a NetCDF is storing. That is y, x, time, and the rainfall. You can see in the workspace all these things are listed here. Let us open our time variable. You can see, and you can see time variable 43465. What is it? And let us go to time variable. To get all the information of the time, let us go to the time variable. It is said that it is a dimension of 366 into 1. What does this say? That is the number of rows and a single column. That is a row vector. And it is unit in days. And since 1900 December 31, the first information of the rainfall that will get is 1900 31st December plus this number of days. The first rainfall information will get. And this 1900 31st December, will call it as datum date. Let us try to extract the information of the time. What will the dates? Let us try to save our days. Days is time variable. Okay. Colon means all the rows, and if we will give comma and write once again colon, that means all the columns. As we are having a single column, no need to give second column. Okay, give semicolon. Just run this section and go to this. You can see that our time format, which was in number, because this time initially is in doubles, our system cannot understand what is this, and we have said to our system this is nothing but the days is the function we have used, and using this function all the time we have saved inside our variable, that is days. You can see. And another advantage of writing in the live script, you can see a preview. Here is the preview. You can see simply the preview. Days 366. Now you can see days has been attached here. Now the system MATLAB can understand what are the information stored inside this variable days are the days only. But where in the time variable you can see no information. The MATLAB compiler is thinking that this is only a some number. Now we have said to the compiler that some information that is in the time is the days. Now what we'll do? Now we'll try to extract the new date. New date. And the function we'll use date is days. Now let me write the code first, then I will tell you what I have done. 01 01 December 1900. Then we have days. This will be equal to, as we are saving this in the variable, this will be equal to, let us fix this one. showing some error. I have given some extra brackets. This one will be for this. Then this will be for this one, correct? And this one will be. Let us try to see what is there in the dates. Days. Actually, we are interested in adding. So I have forgot to write the add. Now, now it is correct. What I have done with this my base date that in 1900 December 31, it will be 31. I have tried to add all my dates that is being listed in the variable dates, and it is now stored in new date, and the new date I have converted it in the string. Why it is a string? Because here you can see some number and here some character and again number. There are also some certain special characters, so that's why we have to save all these things in the form of characters. Now you can see our dates have been listed here. Actually, what mistake we have done, this is we can say now what we have done, now we have successfully saved these dates into our variable, that is new dates. You can see our first date information, rainfall information will begin from 1st January 2020. You can see this NC file here name, it indicates that this file contains information 2020 rainfall information. Okay, it is a leap year, that's why 366 days are there. Now all the dates we have extracted. Now let us break this section, and this code we have successfully run it. Now we'll try to extract the information of latitude and longitude. So in this, here we have some latitude. Let us try to copy some latitude. I'll give you some information about this, and let us paste it is in Excel. And this is the variable x, and let us place it. 20 information let us collect. This is y information, let us. This is x information, this is y information. Actually, what I have shown you and what the information I have extracted from my NC file, that is, look at here, it is 135 rows are there, 1D vector, and latitude, it is also 1D vector. But we generally know that our latitude must be like this. Actually, NC file provides the information of certain grid. Like this is the grid. You can see the dark place is like the grid. This is our longitude, that the x information. This is our latitude. Now let us try to place it. I will try to visualize. Once you will be able to visualize, then you will be able to code it. And yes, this one, this is the y information. Actually, this type of information is provided by NC file what we have received. What it represents that if we have an area and it is having a longitude of 66.5, then it is having some latitude 6.5, we have some information. Here let us have information of rainfall 2 mm, and similarly here we'll have some information, let us say that it will be have 6 mm. This information is being stored in a NC file, that is in the rainfall. We can see 135 into 129. Now you must be able to connect, that is 129, 135. 135 is longitude, 129 is latitude. That's why it is 135 into 129 into 366 in the time direction, that is number of days. Now here all the information will be stored here like this. Now what will be, now the important thing is that how to extract this information, because this cell is having some latitude and longitude. What is that? The longitude is 66.5, then latitude is 6.5. Now what we'll do, now I will try to construct a matrix having this position, and it will be indicated by x and y. What we'll do, we'll have this 6.5 here, 6.5. Then we'll have some longitudes. Okay, like this. Now what we have did, we have geo-referenced all these positions, that the information stored here lies at 6.5, 66.5. Then what? Then another, we have copied it. One second. Now try to construct this type of matrix. Okay, let us try to construct this in MATLAB. For this, we'll be writing a nested loop. That means we have this longitude, 6.5 is the, sorry, latitude. Then this will be linked with all these longitude. Then we'll change the latitude. Then once again link all this information with the longitude. Let us now try to construct this. For this, we'll be writing a nested for loop. Now, lesson of x and y. Let us define it our row equal to 1. Let us take a variable, that is row. Now let us start our for loop. Count equal to 1 equals to 1 size of x, because we have to iterate x times. X means 135 times. X is 135. So we have to iterate it 135 times. So the size information, you can see, let me copy it. See what the size information, the function size will give. It will give 135 into 1. Now let us write another for loop inside. Equals to 1 size y. Then let us do x y x count y count 1 row equals to row plus 1. Let us try to understand this one. What we have done. Let me run this section. There is some error. It's saying that count 1. Okay, this will be count 1 and this will be count 1. Yes. Now let us run this. Let us put here a semicolon. Here also a semicolon. Now I have successfully executed this section. Now my output will be stored in xy variable. This is the variable. You can see the locations we have extracted. This you can see the location we have extracted. And this is of a length of 17415. You can also check that. If we have x value 135 into 129, we have 17415. Now we are able to extract the information. Now what will be our next task? Import the shape file. And let me give little bit of description of this code what I have written here. X and Y are two columns, and using this square bracket I have added these two columns. Using this row variable, I have changed the rows. First I have written, you can see here, I have first written this one, then I have changed the row, I have written this one, and the information that is in the row column 1, you can see 66.5, this one, this is being iterated by first for loop. And in the second column, and this is iterated by this second for loop. And we can see that this is a nested for loop. Then let us go to another section, make another section. Let us try to import our shape file. File that is ROI, region of interest. ROI, the variable name I am giving ROI, and SHP, read is the function. SHP read, SHP, read, save read. And this is the advantage of live scripting, that I have written the wrong command and it gave me no suggestion. Then I thought I have written some wrong thing. Then this is the right function, SHP read. Okay. Then bracket starts, then single inverted comma, then it will give some suggestion. In our folder, it contains one shape file. That why it gave a suggestion, that is BBMD shape file. Then we will show this map. The map so ROI. Now we'll run this command. All the information that shape file contains have been shown here, and the ROI show the map is being displayed. This is our region of interest. All the information that the shape file contains, what are the coordinates? These are the coordinates. Coordinate of this bound. Then other information has been stored here. Let us give a semicolon so that the information which we don't want, we cannot see that. Now let us hold this map for some time. Hold on. Now from this shape file, let us try to extract the coordinate of this bound. How can we extract? Let us extract the x information of this ROI, that will be equal to, we have a function e extract field. Here, extract field is that function. ROI, our file name. What we want to extract? The information of the x. Then similarly, we'll try to extract the information of the y. Y information we'll extract. Don't forget to give the semicolon here, because this shape file contains large number of xy coordinates, and when we'll run that, it will take some time. It will remove the semicolon. That means it will get MATLAB will get some instruction that to display, import the information of x and y from this shape file, and also to display that. While displaying, it will take a lot of time. Okay, don't forget to give semicolon. Now you can see it has all the information of x coordinate, and it now next here all the information of y coordinates, and it is being saved as a column vector. It is having single row and different column, so it is a column vector. Now the important task is that to find out what are the coordinates what we have built here are lying here inside this shape file. So let us make a section points inside our region of interest. Now for that we'll be using in polygon command that is being provided by MATLAB. You can see in polygon. Yes. In polygon is that command. You can see, let us assume this is our shape file, and these coordinates we have extracted from our NetCDF file, and we want to know what are the coordinates that are lying inside our shape file. This is a function. Okay, you can see the x coordinate value here, y coordinate value here. Then once again, and click here, we can go. You can read description of what it will return. It will only return the coordinates which are inside this shape file, and this on command means on will return what are the coordinates on this shape file, means on the boundary what are lying. And this is a logical function. It will return a value 0 1 0 1. If it is lying inside that shape file, it will return 1. If it outside, it will return 0. You can go through this page and you can find how to use this command. I will show you right now how to use this. In, then on. Let us try to extract both the information. In only now first function, the first argument, that is x cube. You can see some hints has been provided by MATLAB. This is the advantage of live scripting. And what is that x cube? That means our the matrix that we have stored, that is x underscore y, and where we have stored, we want all the rows. That's why we have given the semicolon, and we want first column, because the first argument, don't forget that it is a x value. X value means the x column will be stored the first argument. The first argument will be taken by this xy colon 1. Then second is y information. Then all the y information are stored in xy variable x underscore y in the column 2. Now, and what is our region of interest? X, that is x, the x or y, then comma y. Don't forget that this is this xy. You can go here. Xy is a matrix having 17415 rows and 2 columns. But here x ROI is a column vector. Now what we need to do, all important thing is in MATLAB that all the matrix should be compatible. Means in like if you have a if you want to add two matrix, then the n cross n must be same. Like that, these would be in all, means in same format. As this is in row column vector, then we'll give a dash, so that it will convert it into a column vector, sorry, row vector, because dash means transpose. Let me give you an example. Like a, we have stored it as 1 2 3 1 2 3. Let me make it a prime or a dash. Now it has been shifted to a row vector. That means this dash stands for transpose. Now let us run. As I have said, this is a logical function. It will be returning 0 and 1. If it is lying inside this region, it will show that it is 1, or else it will be 0. Let us do not print it. Okay. Now let us extract. As it is in 0 1 format, let us try to extract the actual value. Means actual coordinate. Okay, make a new section. Points inside ROI actual value. Let us mark it as a equal to x y, then all the rows, last column. Similarly, let us save B column 2. Means we have extracted the information of our xy variable, the original matrix. This one, original matrix. A means x column to A, and B y column to B. Okay. Now the actual value x. Let us give it y equal to A B P in. Let us run this command. It's showing some error because I think I have given extra bracket here. Let us run. Oh, sorry, I have in bracket here. Now it is okay. XY in 0. You can see that these are the points that are lying inside my region of interest. Now let us try to visualize these points. For visualizing, we will be using a scatter plot. X underscore region of interest, all the columns, and we have x value, comma. Then we have x region of interest, all the rows. Then we have y values. Okay. Now let us give some color, means yellow will give. Then we'll hold off. And let us keep some heading here so that you will be able to know what is this visualization. Hold up means this map, once we have displayed, we want to display the same points on this map. So we have hold on command. Here we have written. Then we have now hold on. That means now we don't require this map. Let us run this. Here it is showing some error. Actually, oh sorry, this will be 1. Sorry, yellow, because it is in yellow, that's why all the points in yellow we cannot see it. Make it some other color, cyan color. Make it some other color. And this is the command, scatter command. XY in region, the variable which is containing our coordinates, that's the x value. We have extracted the all the x value. You can see here what I am doing. You can see in the command window all the x values. Similarly, we'll have all the y values. The arguments that the scatter function will take, that is xy in ROI, all the x value. Here you can see the preview, what is the variables it stores. And the first column will be taking in the first argument, the second column will be taking in the second argument, and the fill is the dots will be filled. And hold on, when we'll run this, we'll get this map. We have now successfully all the extracted all the points that are lying inside this region of interest. Now what is our task? We have successfully extracted the points. We need to know this position of this point inside this matrix, this rainfall matrix, where it is. So what this rainfall. As it is a 3D matrix, we have extracted the points. We need to know the actual position. Position means index I am talking. Okay, initially what I have shown you, like let me take one example. xy in ROI. Let us take me Let us take this. Let us 84 23. 84 is the x value. This is the x value. 84, sorry, I have not placed all this value. Means 84 somewhere it will come here. Let us assume that this is 84. Let us assume this. Let us assume here it is 23. That means this value we want. Then how can we extract? Because the matrix does not know what is this coordinate. It only knows the position. This is first position, this is second position, this is like that. It will go this position. Because MATLAB is not our this is the coordinates. It knows only the position. We need to find out the position. That means if it is the 13 position, then it is our value means required value is present at column number 13, then row number. Let us take it as like this. Our column row number 12. That means now what we'll do, we'll try to extract the information of the column number 13 row number. For that, first we have to identify our location of this 8423 in our matrix. What we'll do, we'll now try to extract the information. Let me write the code for it. Then I will explain. And in x and y in rainfall matrix. You can see in the NetCDF file that this matrix, the value are known by the MATLAB as a matrix and its index. This 15 is stored in the first column, first row. It, it is not aware about the what is the longitude and the latitude of this position. It only knows the index position. Here it is the this 20 value is stored in the third column, second row. Accordingly, we have to extract the information. Let us write the code. We'll be using a for loop. For count equals to 1, size will be x. How many values we want to search? All the value that is stored in our xy in RY. Then position we want to find x, y, our ROI. And give its count. Then all the columns in all the two column information will be extracted. Then here we'll be using an index called as find. Find returns the index position. What we'll find, where we'll find in the x, y. Then we have written in ROI. Then count, 1 equal to x. Okay. First is over. Then we will find the y value. Y is located where? Then we'll another use. Once again we'll use to find. This same will be using this same. here, and it will be y. Now let us run this. Give a semicolon. Let us run. Now the position. Position. Position where we have stored this variable position here. It's showing only single, but we have made some mistake. I think. Count. This is sorry. This will be 2. Now it is correct. Okay, run this one. Let me see this once again. Okay, I have checked it, and now it has been corrected. You can see all the position have been extracted here. Like my first value lies in x71 row, 67 column. The value like this. The 71 row. Let me like this. The value in the 67 like this. Let us see. This value will be extracted. For that we have extracted all the index value. Okay, now we have successfully extracted the point. Now it is important to extract our rainfall information. What we'll do? For this, we'll be using once again a nested loop, because as we having a x value and a y value, that's why we'll be using nested. Column will be one. Let us start it from first column. For time count, let us take a time count, because the z direction we have that time, isn't it? Time count. How many times the loop will run? Loop will run as many times as the rows of the time is having. Okay, I have fast forwarded this video so that no more time will be wasted for you. So what I have done here, actually I want to print all my values like this. Like this is my first coordinate. Like this is my first coordinate. These values will be like this first coordinate, and for the date 1 I will be having some value. Similarly, for second coordinate, for that same date will have some value. I want to save my matrix like this. For that I need to first extract the rainfall values. What I did, I have used a nested loop. This nested loop, the upper loop will be iterating the time, and in the inside loop will be iterating this xy in ROI. Means all the positions, that is all the position values that is inside that position matrix, and that position matrix will try to extract the information from the rainfall. And how many times this loop will run? The time for time 1 means for day 1 it will extract the information, then for day 2 will extract the information. What we are actually doing, this is the time axis. This z direction is the time axis. And in the for day 1, for this is the position that is lying inside my ROI, we have extracted the information. For the second coordinate, let's say this one, we have extracted this information and we have moved to the second time step. Similarly to the third time step, continuously we kept on running it. Now let us run this section. Yes, this value has been stored. Now we can see I have not written the coordinate values here. Only information I have extracted the rainfall information. And the all the rainfall value we can see rainfall information. The unit is in mm. Now what we'll do? Now what we'll do? We'll try to combine those metrics. Combine the matrix, that is coordinate matrix and the rainfall matrix. That will look total rainfall of our region of interest. We have coordinates. The variable accordingly you can give, there is no issue. I am giving a long variable name so that I can identify what it is, because in this we have used lot of coordinates, sorry, lot of variables, so that if you are using long variable name, so that you can easily identify what you have stored. Now my task is to combine X ROI, then value ROI. And remember, this is a column matrix and it is also a column matrix. I want to place the coordinates above this value ROI XY. So what I will do, I will transpose this one, and this comma signifies that this one will be placed top of this one. Now let us run this one. You can visualize. Sorry, not comma, we have to give semicolon here. Sorry. Okay. Now we can see these two column contains the coordinates, and here sorry, these two rows contains the coordinates, and here this matrix, the column and row matrix, contains the two diagonal matrix. 2D matrix contains the information of the rainfall. Now successfully we have extracted the information. Now what will be our task? Now let us try to input all the values that we have extracted here into a Excel sheet. What we will do? Now let us break this section. Then we can use write matrix function. Matrix here, write matrix. Then what is our variable? This one is our variable, and we want to save this one inside a final rainfall extension X. Now we can go to our default folder. Yes. This contains our coordinate. This is our rainfall value, and this is for our first date, second date, third date. Here we have saved the dates. You can see where is our dates. This one is our date, and you can see these things. I think you can paste it here. Yes. Now we have successfully extracted our matrix. You can also do it in MATLAB. Here you can add this. Here you can add this vector, that is character vector of the new dates. You can add this, and this is the altogether all the information I have provided about this NetCDF file. How to extract information, how to get the information for region of interest using save file. And thanks for watching. Please like and subscribe my channel. Next time I am going to come up with how to make keep files from this NetCDF file, and this file link I am going to get it on and upload this one on the GitHub in my profile, in the GitHub profile. Please follow also me on the GitHub. Thank you. Thanks for watching.